So we started basically this effort about in Facebook about a year ago, where we wanted to go with higher precision of timing, synchronization, and that was mainly PTP. And basically, the problem in hand was twofold. We had the why and we had the how. It's like, why should we do this, and what does it take? So, and it was very hard because it was like not only a chicken egg, it was like probably 2 chickens and eggs. So anyways, going down the road, we were super lucky, I will say, that we had Michel. So Michel has been familiar with PTP longer than the world is familiar with it. And the reason is because he was John Eitzen, one of the co-founders of PTP's intern that time, about 20 years ago. And so he has been part of a lot of, let's say, different profiles in telecom, and it was great to basically, the moment I approached him and told him about like what we want to do, he was on board, and he's been like a solid rocket booster, I will say, for this project. And I don't know if Georgie is here too. So then not very long after that, we found Georgie, which came, it's a software guy. He came from different backgrounds, like, I don't know, in Microsoft and like, I don't know, other industries, like which they touched basically this accurate timing for databases. So all of a sudden we had pretty much the how we should do it and why we should do it. And then we kept like working on that. And as we start like reaching out to the ODMs and the suppliers and like different like kind of manufacturers and everything, we realized that there is a discrepancy between them, and every one of them like are trying to basically fulfill certain customers that they have, and therefore most of the upgrades in the hardware were still like falling behind. And when we were asking, like, I mean, as simple as, let's say, as of today, you will have a hard time finding a quote-unquote grandmaster, the time supplier, anything with a connection better than 10 gig. And when you ask like why, they say, well, we didn't have the need for it. And then the customers, like, I mean, they were like, okay, yeah, great. Facebook, how many you gonna buy from me? I mean, Facebook at like a full deployment, maybe we'll buy 100, and that's it. And it's very hard for them to justify the R&D costs, or they will end up selling us a server with just like a simple rubidium clock and a GPS receiver for, let's say, $200,000, which doesn't make sense either. So this is where we thought like, okay, maybe it's time to put all the customers on one side and the ODMs on one side and bring them in one forum that they can all discuss with each other, and we can basically share ideas, like basically have forums that we don't need to have lawyers there. Like, for example, today I cannot put a meeting, let's say, for 2 or 3 different vendors and bring them in one room and discuss ideas. But with this, I can take my Facebook hat off, so everyone else, and we sit down here and work with one goal, and that is like how we can work toward this open compute project. So without further ado, let's dig into the presentation. Michel, go ahead.
Yeah, okay. Yeah, thanks, Ahmad. I hope everyone was able to see the wiki. There's quite a lot of some information on the wiki as to what the proposal is about. There's also the slides are on that wiki for downloading. Before we jump into the slides, there's just to follow up on what Ahmad said, there's a couple of trends that we know in the industry. For instance, there's definitely within the data center itself, there is a need that is growing for what we call time-sensitive applications, right? So anything that requires, some level of accuracy, reliability, with respect to time. We also know that outside the data center, so if you look at, from within a data center and you look at it external, there's quite a lot of a need or applications that also rely on time synchronization. For instance, the telecom industry, as well as, quite a large number of mobile operators also that source synchronization from a centralized, point within the network for their own particular application. Another trend is, the semiconductor companies or the silicon, vendors have invested for quite a long period of time now in various R&D projects and effort to really enable time synchronization, distribution, at the chip level, bringing a PTP awareness as close to what we call the medium as possible. We also know that there's quite a lot of various equipment vendors, like Ahmad said, in different industries that are building what we call timing appliances. And timing appliances could be network switches, time distribution, and so on. And finally, there's also this growing trend about using open source PTP software stack. So for instance, things like PTPD, Linux PTP, PTP4L, for instance, right, are really growing, in terms of interest. And one of the questions there is, how does that, body of work, for instance, fit with, what else, we've just mentioned earlier. So let's move. We've got 7 or 8 slides to go through. If there's any questions, feel free to ask any questions.
Yeah, can I ask one question here?
Yep.
This is Lauren Staley. So Facebook and stuff, what in data centers and stuff where you're not trying to get to a really accurate time situation, what do you use now for distribution or timing sync between nodes? Is it just NTP, or is there something else that's that you guys have latched on to up to this point?
Yeah, Kelvin, do you want to take?
Yeah, we're using NTP at this point.
So by the way, Kelvin is our TPM for timing. So prior to this initiative, he was managing basically NTP alone, but then now we have basically PTP as well. And yes, to emphasize, we've been until today. Hopefully, soon we'll switch off. Like we'll basically have in addition PTP, but right now we are only relying on NTP.
Yeah,
okay,
we use Stratum 1 appliances in our data centers across the world. Basically, is where we get our NTP from. Yeah.
Yeah, and I think say that NTP is a core technology, obviously globally, and certainly within the data centers. Okay, so we're on slide 3 for those that have downloaded the slides, the background slides. So very quickly, here what we're saying is that quite a lot of vertical industries in the past 5 to 10 years have spent a lot of effort addressing various needs when it comes to time and frequency delivery over packet networks. We've listed in that table quite a lot of industries, and from a very high level, the type of applications that require that notion of time and frequency. What's really a common across all of those verticals is they all have a need for synchronization. And what's even more common is that all of them have developed or are being developing what we call PTP profiles, or serving their needs using PTP and various other synchronization technologies. Slide 4. In terms of organizations, I think we've touched that a bit, myself and Ahmad at the beginning. There's various bodies in the industry that develop these kind of specifications for their own particular use case scenarios. There's quite some of them are listed here. Most of them, if not all, refer to 1588 or precise timing protocol as one of the baseline or the baseline method by which they achieve their needs for their particular use case scenario. This open source software that we've referred to, Linux PTP as an example, is really growing in the industry. There's quite a lot of different industries looking at adopting Linux PTP, even including a telecom and mobile world. Again, what I said earlier about the investment that was done by the silicon companies to really embed synchronization capabilities as close to medium as possible, right, down into the hardware. There's various test and measurement equipment companies now that are coming out with various testers to validate various requirements across these these industries. And again, various timing appliances that are being developed by a lot of equipment vendors. In terms of we've also listed a couple of conferences, for instance, that specialize in the topic of synchronization, like ITSF, WSTS, ISPCS. What's interesting to find in some of these conferences is many years ago, these were driven primarily by the telecom world and the mobile world. But more and more, you can see that there's more and more talks about how do we use time into the power industry? How do we use time into the financial industry, and how do we use time also within the data center industry? So that's really nice to see that there's a large body of people or wealth of information that is gravitating or being generated by some of these conferences, and of course there's a
one thing I wanted to add is like again, for years we were taught, like in academia, in industry, that when you have a distributed system, you don't have a accurate clock available to everything, and then you don't have, like, you have basically this you shouldn't have like a single point of failure and so on. So I think Georgie can add a little bit to that. Georgie, can you please add a little bit to this before Michel continues on the charter?
Yeah, of course. This is Georgi from Facebook. I work on distributed systems, storage systems in particular. So we have a great example in industry. Google Spanner proved that relying on clocks, accurate clocks, is actually a viable business solution. Google Spanner is quite successful. It's a distributed system that works across continents and provides high availability and also very low latency. There are a few other places where in distributed systems where we can use reliable and precise clocks. External consistency is one of them. We can use this for cache consistency. We can use for authentication tickets. There are multiple places where we can replace communication with local calculation. And that's quite beneficial when we talk about long distances where the latency is limited by speed of light, and we see a replacement of messages that takes about 80 to 120 milliseconds with just looking at the local clock. That can be that can change drastically the throughput of the system by not limiting the correctness or creating additional problems.
Okay, Michel.
Yeah, thanks.
Let's continue with the charter then.
Yeah, very good. Thanks. So in terms of the charter, there's a couple of bullets here. We can go a bit. One, this is the proposed charter. Obviously, I think we've covered a few of these points already, but this aspect of openness and timing appliances and the various interfaces and the various open source PTP software implementations that exist, and how does that gravitate towards the infrastructure itself? How do you use that into, for instance, network switches, routers, servers, time receivers, time distributors themselves? Obviously, one thing as part of that charter is to bring that community of expertise and wealth of information that exists from data center operators application developers like what Georgie just referred to, equipment and semiconductor vendors, to really enable these time-sensitive applications that exists within the data center, but also look at it from a fresh set of eyes as to how can that also be used from a distribution point of view towards external type of applications. And obviously, as we go through this, one of the firm or deliverable of that charter would be to create some specifications. For example, things like intra-data center application and the various timing appliances that could be used or would be, OCP compliant and PTP aware, right? Not all timing appliances today are PTP aware. So the question, needs to be asked about, okay, how do we embed PTP awareness in some of these appliances, and what does it look like at the end of the day? And of course, the last point is to really, engage with other OCP projects, including networking, storage, server, and obviously the telco, project that have their own set of needs for, synchronization. In terms of the scope and goals, so again, these are, proposed scope and goals, is to really look at from, a data center point of view, what would, the network architecture look like, the performance objectives and how you decompose, those performance objectives within the data center to meet a certain, for instance, a time error budget. How do we also, not just from a performance point of view, but, as important or more importantly, how do you really, operate and monitor, time distribution and synchronization, across, a data center? And, if there is a point where the industry probably, in my opinion, needs a bit of work, is in all of this operationalizing and monitoring, time distribution, PTP type of network. This is where a bit, there's a lot of the standards have not necessarily, really come together to address, that need or that gap, if I could say. So one of the things, would be to, in point number 2, to develop, a data center PTP profile and some best practices. All other, verticals have developed these kind of profiles. Basically, the profile is just a way for you to advertise, or for the community to advertise how you do things. For instance, for a particular use case scenario, and details on specified attributes, configurable parameters, and so on. With the objective of really helping the community gravitate towards implementing something that is consistent and something that is, interoperable, over time. In point number 3. Yes, of course.
Yeah, this is Derek Alden. I'm a technician at the University of New Hampshire Interoperability Laboratory, and I'm wondering why the existing PTP profiles are not useful for your use case. Because as you mentioned, there are several existing PTP profiles that kind of run the range of what scenarios they cover, including telecom all the way down to automotive, as well as there's a recent release, the 1588-2019 standard, which includes a profile called White Rabbit that CERN has been producing that is used for sub-nanosecond precision. So there are a lot of existing profiles, and I just wonder why you're looking at developing a new profile instead of adopting one that fits your use cases.
Yeah, very good question. So you're totally right that there exists a number of profiles, and certainly as part of that, the proposal here would be to refer or use, whatever is applicable to the particular use case scenario. There's definitely no need to reinvent the wheel. For instance, if unicast negotiation, as an example, has been widely adopted, in some profiles by the telecom, you can use that. You can build on that. You can use the, the open source Linux PTP that offers, for instance, unicast negotiation today. Okay, I'm giving you a specific example, but there are also gaps, right? So for instance, within a data center, an operator might be running IPv6. Well, IPv6 is not necessarily something that has been well thought through or well specified, in a lot of these profiles. Ahmad referred to things like, above 10 gig interface. None of these profiles specify, the use of 100 gig interfaces, today. Certainly, if you look at the time distributor and you're trying to procure a time distributor with a 100 gig interface today, that would be a good luck situation. Yeah. So these are the kind of things that we need to look at it from a a gap point of view. And obviously,
one more thing I can add is, for example, I'm assuming like you're familiar with like either you can have accuracy or you can have holdover. So, or like for example, how you want to architect the network. Let's say most of these networks in telecom, specifically again tailored for telecom for 10, 15 years right now, being the main customer for it. Most of these the standards and profiles are tailored to work in series. Like when you have like a lot of hops and you want to have like things, let's say, working very well as you go through hops. While in data center, you're dealing with different animal. Like you have things more in parallel, while the depth is not necessarily that much. So yes. When we basically reach out to existing vendors for Grandmaster, and we told them like everything was first like, oh yeah, we have to upgrade the thing to 100 gig and so on, like IPv6. There was a lot of resistance at that point, but check this out. The moment they were like, okay, what's the maximum of clients you're going to have on basically the Grandmaster has to basically serve? Like, yeah, we're good. We can handle up to 500. We're like, anything that's less than 5,000, we cannot even imagine how we're going to build the structure. So you see, like there are a lot of things, there are a lot of needs that are very specific to this architecture, because again, as an engineer, you always try to fit things, like you try to stay away from overfitting. You try to fit things with whatever is in your hand. And that's why we thought like, okay, instead of going to every vendor and talking from A to Z, describing everything like what we need and so on, we have a profile. Are you like compatible with this profile? Yes, no, voila. And again, we brought it up, even you mentioned like PTP 2019. We had a meeting right after that with John Eitzen. Basically, we're lucky that Michelle knows him. And he also saw like, yeah, definitely there's a need to basically put this thing as a new thing there, so we can just steer, let's say, our customers, if they want to get into datacom world, here is the blueprint.
Yeah, hi, this is Alon Regev from Keysight. So I just have a couple of comments to make. First of all, I agree with everything that's been said. I think it makes complete sense that there is a new profile. What we're doing here is fundamentally different. Yeah. With regard to similar profiles, you should take a look at 802.1 CM and what's being done in the front haul market, because I know there are several vendors coming out with grandmasters that work in the 25 gig to 400 gig domains this year, specifically for that market. And I have no business relation with any of them. So, also, a lot of there is silicon being developed to address that market that again, may be useful, or we may want to get involved in the discussions here.
Absolutely. Alan, you mentioned something very important, and that is basically if there are, let's say, certain vendors that they're already doing something that we can need, right? That we can use. And by putting this up, I can basically attract those things to come in. I don't want to reinvent the wheel.
Absolutely.
I prefer to take off the shelf if it exists. But on the other hand, this is a little bit different than my previous life in academia, which I have to do literature review or something. I rather have this open. They are looking for things, and now there is an entire existing body of, guess what, all this quote unquote, let's say, customers that they may need this, and they agreed, let's say, on one profile. So as a vendor, you have such a good way to see, like, okay, here's my market ready, and let's say 4 or 5 big players are only looking for this, agreed on certain standards. But very good question, very good comment, actually.
Yeah, very good questions from definitely from both of you, and thanks for this frontal initiative, like you said, is bringing in things that should bring awareness into what is proposed here. One thing I just want to on this slide is again, this aspect of tooling. This is very important also. So anything about operationalizing this and monitoring, and testing this, pretty much on the fly, and making corrective actions and so on. That is something else also. And the development of data models, right? Underlying information and data models is another, big body of work, or some piece of work that is very important, for this use case scenario here. Okay. In terms of engagement, we've got a bullet here where the engagement would be done like through the typical OCP engagement, technical meetings, and contributions, as far as I understand how it's done. I think we're on slide 7. I don't want to dive into the details here, but I think a lot of people that are in the know will appreciate a little bit better. Here's just a mapping of a hypothetical reference model or architecture, and some of the points that we just discussed here, and how do they map there. So there's quite a lot of when you look at this, there's quite a lot of this whole aspect of time, station, and the architecture and all of these points, and how we need to discuss that and specify that is in play here. And then on slide number 8, this is just basically a recap of the initial slides, what we went through. So again, the proposal here is this time. This is a project, or the acronym is TAP. There's a a logo on the right-hand side, and there's a small a blurb here of information as to what the mission is about here, and specifically for as a start for data center specific time sensitive applications. And then this is a bit,
I have a question on this slide, if you would. Back to your the focus, I guess, at the top. So the focus is very broad, covers everything from specifications to components, and everything in between. So that's fairly broad, and it's specific to the data center. So within OCP, we have the telco group who's just starting to talk about perhaps making hardware modules, timing modules, or timing designs, the hardware circuitry, standardized across telco type products. And then I know in TIP, they're talking about coming up with perhaps a standard API to configure attributes of that underlying hardware that's needed to be common across hardware, such as configuring the PLLs and stuff like that. So out of those two examples, so perhaps a common timing module and a common configuration API of the underlying circuitry, are either of those going to be part of this project? Because reading your focus here, it seems it would be.
Yeah, I think you bring a very good point, and these are the kind of discussion items that we will engage in. We'll certainly discuss, and I really like what you just said about this common aspect the more we can commonize, or this is not the right term, a lot of these things, the better it's going to be for, all of the various use cases, scenarios out there. And one of the things that, we mentioned previously is to really engage with, other OCP project groups, right? Including the telco project group, working the storage, and so on.
For now, we want to have this platform which we can basically bring all these different, let's say, I don't know, needs and requirements together. And like specifically, like I want to have this platform which we can have different vendors basically talk together and with the customers, and then we can like basically rule out certain things. If telco, if our friends in telco, like they have certain needs or so on, and they're related to time, absolutely, we can always shape these things in sub-projects basically on this time appliances thing.
Yeah, I'm wondering if you're going to leave your, I guess, the high-level focus or beginnings of our charter here for data center specific, or you're going to make it more generic than that?
Well, from what we are thinking, we're envisioning, it's like even in telco, I mean, like there are certain parts of telco that they require like accurate timing on the radio side and so on. I think they're pretty much covered very well from ITU and like other standards, whatever it's around there. But let's say the backhaul part and like there's a term for it, I forgot. Like the data center similar part of it is where I think we can help a lot basically with this.
Oh,
that's like
okay.
Actually, they're not.
They're not, okay, sure. Go ahead.
Actually, the telco part indeed require very constrained time in the deployment that being involved in the edge. But apparently, up until now, most of the time-restricted server are not really a server. They are not a commodity server. They are hardware appliances. And what we're trying, I hope that this approach will lead to the fact that an OCP server will be able to serve those markets as well.
Yeah.
And allow softwareization of those parts, because the time-sensitive part is the restricting one from software to be deployed.
Yeah. So very good. Thanks for asking that question with regards to OCP telco. It's actually important that this gets discussed. I see two things now a bit we've been discussing, and what we've said is there's a need to develop that data center PTP profile, some profile, and a very technical or specification work. And then there's another one that exactly what we are having now is having these kind of discussions about how do we make things more in common, right? How do we bring some uniform into a lot of the same problems that some of these use case scenarios are facing. So really good to hear. Yeah.
And by the way, reiterating what was just said, I see a lot of parallels with the telephony side of the world, in that they're trying to virtualize and move to software-based appliances, just like the data center world. So the trends are similar. They're not doing exactly the same thing, but the trends are similar. So again, I think there's a potential ways we can the two worlds can work together. They can gain something from this effort.
Wonderful.
So I have a question for Michelle. Are we going to consider other technologies like SyncE, or we focus only on 1588? There is also work in the academia, like the paper I sent yesterday from Stanford,
yeah,
where they developed even better time synchronization scheme, which can go up to nanosecond synchronization, but doesn't use 1588. So is this project open to consider other technologies?
We've asked definitely some discussions on that as the as part of the initial team. Ahmad, do you want to give a quick answer to that? But my answer to that would be yes. It needs to be factored in. Just like White Rabbit, someone mentioned White Rabbit.
Yeah, Hisham, we've been actually in touch with Balaji's team, like you're talking about Huygens and
exactly. That's Balaji,
So like we're open to all of this, and I'm in blood and academic, so this is definitely going to have a lot of like I'm really open to have this for more discussion of the new technologies and everything. Like absolutely. This hopefully will serve as a platform to bring in like all these new ideas and everything. Hopefully we'll have like our own track, let's say. Again, this is just the start.
Excellent. The other thing is you may be aware of the IEEE 802.1 time-sensitive networking project, which there are two sub-projects under this one for industrial automation and one for cars, automotive, and lots of work, as you may know, related to time-sensitive applications, which use IEEE 802.1 AS Rev or .1 AS. There is also, as somebody mentioned, .1 CM for front haul, which also use time synchronization. So maybe that project can tap into what is going on in TSN and find some synergy. But again, TSN is not just for data center; it is for industry, for a factory, for front haul, or for other applications, not just data center.
Absolutely.
Yeah, very good points, Nishan. Thanks for bringing that up.
I want to emphasize one of my ideas that I think will be very much compelling. We believe that the approach of commodity server that has time synchronization characteristic and reference could be very well exploited by the telco, but we're also thinking that the vice versa synergy could be done back. The telco introduced PTP profiles that include, with respect to the timing restrictions, not just a low bar for the time-bound error, but also some nice filters that allow to really lower the bar in synchronization and to be noise tolerant when you build a big network. We would like to take this approach and bring it into the data center to make a PTP deployment in scale very much robust.
Wonderful.
Yeah, very good, Dotan. Okay, the last slide out of that deck is basically shown here. It's just the initial team that had particular discussions or some discussions on that whole subject to date.
Yes, the initial team is basically the team that helped to form where we are at this point, and we're open for everyone who is interested, wants to collaborate and contribute in this. Michelle, can you go back to it, because I just wanted to go. Of
course.
So collaborate on this side. Again, on our side from Facebook, we started this. We love to see other I don't know, partners from our end, in the datacom industry. And we have also from the vendor sides Mellanox, Broadcom, Intel, and whoever else wants to join. So we have Elad and Dotan here. They joined a little bit later, so I couldn't introduce them. So they've been very helpful, again, in even shaping this idea to come in. So that's why Dotan and Elad are helping with the initiation of this in terms of leading it. And we'll have this interim period, and we want to have this thing basically going forward with more contribution from everyone's side.
Yeah. And then also the test and measurement equipment, industry also.
So I'll say a lot of this, again, the idea of putting this unified body where we can all talk together actually came from CalNext, because they're at this moment like basically serving a lot of, let's say, different both customers and vendors, and they've been having a hard time always like coming up with like all this diversified, like, let's say, needs, and that was where we realized, okay, let's make these guys' life also a little bit easier, because they're trying to serve everyone, and everyone's asking them for different things. Like they came here with like, oh, we want IPv6. They didn't have it. They had to push very hard to get IPv6. The moment they were done, we asked them for some other things, and like it's been just ongoing. So that's why we thought like, okay, time to make this more public, the needs, and then have like all other stakeholders. Let's say I come up with something as a requirement, and then I have my partners from, again, not vendors, let's say, I don't know, other partners, and then they come back to me and say, oh, you don't need that. You can solve it like this way. And we can argue on that till we find, like, let's say, something that's a common ground. Then we can present it back basically to the vendors, so the vendors have like a more focused like objective that they can serve in the same time more customers.
Yep. So Ahmed, this is Archana. Couple of things just as housekeeping as we wrap up the call. Number one is this call is set up every 2 weeks at the same time. So it'll be, you know, on Wednesdays here. And if this time is not amenable to those, you know, like Dotan and Elad and others that are trying to join in from other parts of the world, I'm sure there are other people also on the call from other geographies. Please let us know on the mail reflector so that we could try to find a time that works better for everybody. Maybe it's earlier in the morning or later in the evening. This is obviously just the first call, and we wanted to get everybody together to start having that conversation. But if the time doesn't work and we want to have more engagement from other parts of the world, let us know. Number two is Ahmad and Dotan and Elad and team, even Michelle, we can give you guys wiki admin rights. So if there is anything that, you know, people want to post on the wiki as good information material, like the Stanford paper or something like that, then we can start adding that reference material to the wiki, and that becomes our repository for, you know, just communication, right? Instead of trying to flood everyone's email box with the emails to the reflector.
Okay.
Third thing I was going to mention is that, you know, we're getting a lot of really good momentum. We have 30+ people on this call. There seems to be a lot of really good interaction. OCP is looking at putting an engineering week together in November. So that is our target right now, the week of November 9th. And what I would love to see out of this incubation project is maybe some working initiatives, working, you know, specifications or things like that that we're targeting, that, you know, we can congeal around and then present it to the broader community during that week. And that week is intended for really deep technical, you know, dives. So like a full day of what we just did today. It's going to be very technical. Roll up your sleeves. It's still going to be very virtual, but unfortunately, that is the environment that we're in. But to give you the opportunity to just start that conversation and continue it, so that we're not abruptly having to stop at the end of the hour, right? So that's also there in November that we're targeting. So I'll send you, you know, a note later on this week, and we could start kind of looking at a very high level agenda. It doesn't need to be anything structured. It can be a lot of open discussion. It can be a lot of, you know, presentations. Just depends on how the team wants and the community wants to do this. And the last thing is that I think, and I'm not sure, but Rajiv is on the call, and we'd be setting up a GitHub repo under OCP. And so if there's any kind of interaction that needs to happen on the GitHub side, I think that would be the place to start that collaboration as well.
That's
so
wonderful.
Not only do we have the wiki, but we also have the GitHub. And then, of course, these calls are going to be recorded. So if you have colleagues that are interested, please just refer them back to the wiki and the mailing list.
So Archana, this is Richie. You're spot on, and that was one of my questions that I had, and I thought probably I should wait for the next call to Ahmed and Michelle, was that if there's any code that has been already written or any specification that is half baked in or anything that is worth putting it into a common portal, I think would be very helpful to the community.
Yeah, Rajiv, like I think for the beginning, we can actually start with the PTP profile, the datacom profile, which Michelle and I have been digging into it for a while now. We can put it there, and we can have right away everyone putting their input. It can get better.
That's wonderful, Ahmed. Yeah. So what I will do is let me create a GitHub repo and share some details with you guys soon.
Wonderful.
Yeah, just put the link, send the link either to myself or Michael or Ahmed or Elad, and we'll put that link also in the wiki so that everything is kind of connected. And then I guess the last thing that I wanted to just kind of throw out there is that would a Slack channel be of interest to this group?
Well, that can be of interest. I don't want to sound biased, but would you guys also be okay with a Facebook group?
It just all depends on what the community wants to do.
I don't want to sound biased.
Maybe the question.
Ahmed is creating demand for his own platform.
No, but we could ask ourselves
in the slumber party.
That question during the first call.
Yeah, I think we could do a survey as well and just send it out.
Oh yeah, I love surveys.
So I think that would be a really good way of doing that. The other thing that we could throw in the survey is, maybe another call time, if that works.
Absolutely.
People can either pick this call time and stick with it, or opt for. We can give them a few other options.
Absolutely.
Okay. Very good. Yes. Yes.
So I'm assuming that in 2 weeks to meet back together, is that sufficient time, or do you think that you'd want to meet on a weekly basis?
No, 2 weeks is good. 2 weeks is good for now. And then if
now,
material gets jammed in, we go for like shorter periods.
Perfect. All right.
Yeah.
So I just wanted to kind of end with some housekeeping here. So just so that we have it. And in the chat, I have put the link to the mailing list. I have put the link to the wiki. So please go ahead and refer to that. And like I said, the recording, as soon as the recording is up and running, we'll send a note out to the mail reflector again, just to let people know that it's there.
Beautiful.
Good. Very good. Thanks, Arsha, for setting this up. And thanks everyone for all of this interaction and good questions. Yeah.
Thank you, Ahmed and Michelle. We look forward to do it.
Thank you.
Yeah. Thank you. Bye-bye. Have a nice day.
Bye, everyone.
Thank you
All
all.
right, have a good one. Thank
Bye,
you.
everyone.
Bye, everyone. Stay safe.
Thanks, everyone. Bye.
Bye.
Yep. Take care.